Welcome students. You are welcome to third part of chapter 2 in unit 3 higher order linear differential equations. In the second part of chapter 2 we learnt how to find general solution of non-homogeneous linear differential equations of order n with constant coefficients for which the non-homogeneous term is e power ax. To continue with the same chapter, we move on to learn about to find the general solution of non-homogeneous linear differential equation of order n with constant coefficients for which the non-homogeneous term is sin ax or cos ax. Now we are going to learn how to find particular integral yp for non-homogeneous linear differential equations of order n with constant coefficients for which the non-homogeneous term is sin ax or cos ax. Let's see the working rule for finding particular integral of f of dy is equals to q of x when q of x is equals to sin ax or cos ax. If yp is equals to 1 by f of d into sin ax, then put minus a square for d square, a power 4 for d power 4, minus a power 6 for d power 6, and so on in f of d to calculate particular integral yp. Now we have the new representation of particular integral yp like this. Yp is equals to 1 by f of d square into q of x, which is equals to 1 by f of minus a square into sin x. Also we have another representation. Yp is equals to 1 by f of d square into q of x, which is equals to 1 by f of minus a square into cos ax. Here we have two cases. F of minus a square is equals to 0 or not equals to 0. First, we will see the procedure to find particular integral yp for the case f of minus a square not equals to 0. Let's see the procedure to find particular integral for the case f of d square is equals to f of minus a square not equals to 0. For this case, we follow this procedure. When ultimately f of d becomes linear in D, say, of the form d plus alpha, by substituting minus a square for d square, a power 4 for d power 4, minus a power 6 for d power 6, and so on in f of d, then we proceed as follows. Now our particular integral yp is of the form 1 by d plus alpha into sin ax. Here we multiply and divide with d minus alpha for the expression 1 by d plus alpha into sin x. Thus we get d minus alpha by d plus alpha into d minus alpha of sin x. Here in the denominator we have d plus alpha into d minus alpha. This can be written as d square minus alpha square. Thus we get d minus alpha by d square minus alpha square of sin x. Now in the denominator, in place of d square, we write minus a square. Thus we get d minus alpha by minus a square minus alpha square of sin x. This can be written as 1 by minus a square minus alpha square of d minus alpha into sin x. This can be written as 1 by minus a square minus alpha square of d sin x minus alpha into sin x. This can be written as 1 by minus a square minus alpha square of d by dx of sin x minus alpha into sin x. Here we know that d by dx of sin x is a times cos x. Thus we get 1 by minus a square minus alpha square of a times cos x minus alpha times sin x. Thus 1 by d plus alpha into sin ax is 1 by minus a square minus alpha square of a times cos ax minus alpha times sin ax. Similarly, we proceed for the non-homogeneous term cos ax. Thus Thus, for the case f of minus a square not equals to 0, we have a particular integral 1 by d plus alpha sin ax is equals to 1 by minus a square minus alpha square of a times cos ax minus alpha times sin ax. Similarly, the particular integral 1 by d plus alpha into cos ax is equals to 1 by minus a square minus alpha square of minus a times sin ax minus alpha times cos ax. Let's see some example problem for the case f of minus a square not equals to 0. Example, solve d cube y by dx cube plus d square y by dx square minus dy by dx minus y is equals to cos 2x. Solution. First write the given differential equation. Next, write the symbolic form of the given differential equation, which is f of dy is equals to d cube plus d square minus d minus 1 of y is equals to cos 2x. Here, f of d is d cube plus d square minus d minus 1. So, we write the auxiliary equation for the given non-homogeneous linear differential equation like this. F of m is equals to m cube plus m square minus m minus 1 is equals to 0. Using synthetic division method, we can find the factors for the auxiliary equation. Thus, we have m minus 1 into m plus 1 into m plus 1 is equals to 0. Thus, we have m minus 1 is equals to 0, m plus 1 is equals to 0, and again m plus 1 is equals to 0. Using these equations, we get the values of m like this. M is equals to 1, m is equals to minus 1, and again m is equals to minus 1. Here the values of m are roots for the auxiliary equation. So we can write the complementary function for the given non-homogeneous linear differential equation. Thus we have yc is equals to c1 times e power x plus c2 plus c3 times x of e power minus x. We know that our differential equation is non-homogeneous linear differential equation with non-homogeneous term cos 2x. So we find the particular integral yp for the given non-homogeneous linear differential equation. Here we observe our a value is 2. So we can take a is equals to 2. And we know that f of d is equals to d cube plus d square minus d minus 1, which can be written as d into d square plus d square minus d minus 1, which will be equals to f of d square. Now find f of minus a square. Put d square is equals to minus a square in f of d square. We get f of d square is equals to f of minus a square, which is equals to f of minus 2 square, which will be equals to d into minus 2 square plus minus 2 square minus d minus 1. Solving this expression, we get minus 5d minus 5, which is not equals to 0. Therefore, we have f of minus a square not equals to 0. Here we have the case f of minus a square not equals to 0. So we get our particular integral yp like this. Yp is equals to 1 by f of d square of q of x, which will be equals to 1 by f of minus a square of q of x, which will be equals to 1 by f of minus 2 square of cos 2x, which will be equals to 1 by minus 5d minus 5 of cos 2x, which will be equals to minus 1 by 5 into 1 by d plus 1 into cos 2x. Here 1 by d plus 1 into cos 2x is of the form 1 by d plus alpha into cos ax, which will be equals to 1 by minus a square minus alpha square into minus a times sin ax minus alpha times cos ax. Thus we get minus 1 by 5 into 1 by minus 2 square minus 1 square into minus 2 times sin 2x minus 1 times cos 2x. Here alpha value is 1 and a value is 2. Thus we get the expression like this. Minus 1 by 5 into 1 by minus 2 square minus 1 square into minus 2 sin 2x minus 1 into cos 2x. Thus we have minus 1 by 5 into minus 1 by 5 into minus 2 sin 2x minus cos 2x, which will be equals to 1 by 25 into minus 2 sin 2x minus cos 2x. Therefore, yp is equals to 1 by 25 into minus 2 sine 2x minus cos 2x. Therefore, we get yp is equals to 1 by 25 into minus 2 times sine 2x minus cos 2x. Thus, we have the complementary function and particular integral of the given non-homogeneous differential equation. Thus, we write the general solution like this. Y is equals to C1 times e power x plus C2 plus C3 times x of e power minus x plus 1 by 25 into minus 2 times sine 2x minus cos 2x, which can be written as y is equals to C1 times e power x plus C2 plus C3 times x of e power minus x minus 1 by 25 into 2 times sine 2x plus cos 2x. Working rule for finding particular integral of f of dy is equals to q of x when q of x is equals to sin ax or cos ax for the case f of minus a square is equals to 0. When f of minus a square is equals to 0, we have d square plus a square is a factor of f of d. Then our particular integral yp, which is 1 by d square plus a square into sin ax, which will be equals to minus x by 2a into cos ax, and also the particular integral yp, which is 1 by d square plus a square into cos ax, which will be equals to x by 2a into sin ax. Let's see some example problem for the case f of minus a square is equals to 0. Example, solve d power 4y by dx power 4 minus y is equals to sin x. Solution, first write the given differential equation, which is non-homogeneous linear differential equation with the non-homogeneous term sin x. Next, write the symbolic form of the given differential equation, which is f of dy is equals to d power 4 minus 1 of y is equals to sin x. Here f of d is d power 4 minus 1. So we write the auxiliary equation like this. F of m is equals to m power 4 minus 1 is equals to 0, which implies m square whole square minus 1 square is equals to 0, which implies m square minus 1 into m square plus 1 is equals to 0. Thus we have m minus 1 into m plus 1 into m square plus 1 is equals to 0, which implies m square plus 1 is equals to 0, m minus 1 is equals to 0, and m plus 1 is equals to 0. The equation m square plus 1 is equals to 0 gives the value of m like this. M is equals to plus or minus I. Next, the equation m minus 1 is equals to 0 gives the value of m like this. M is equals to 1. Next, the equation m plus 1 is equals to 0 gives the value of m like this, which is m is equals to minus 1. Thus, the values of m are plus or minus I, 1 and minus 1, which are the roots of the auxiliary equation for the given non-homogeneous linear differential equation. So we write the complementary function for the given non-homogeneous linear differential equation. Here the roots are real and imaginary. So we have the complementary function like this. Yc is equals to c1 times e power x plus c2 times e power minus x plus e power 0x of c3 times cos x plus c4 times sin x. We know that our differential equation is non-homogeneous linear differential equation with non-homogeneous term sin x. So we find the particular integral yp for the given non-homogeneous linear differential equation. Here we observe our a value is 1. So write down the a value 1 here. And we know that f of d is equals to d power 4 minus 1, which is expressed as d square into d square minus 1, which will be equals to f of d square. Now find the value of f of minus a square. Put d square is equals to minus a square in f of d square. We get f of d square is equals to f of minus a square, which is equals to f of minus 1 square, which can be expressed as minus 1 square into minus 1 square minus 1. By solving this expression minus 1 square into minus 1 square minus 1, we get the value 0. Therefore, we have f of minus 1 square is equals to 0. Here we have the case f of minus a square is equals to 0. And we know that f of d square is equals to d square into d square minus 1, which is equals to d square whole square minus 1 square, which can be written as d square minus 1 into d square plus 1. Therefore, f of d square is equals to d square minus 1 into d square plus 1. Here we have the case f of minus a square is equals to 0. So we write our particular integral yp is equals to 1 by f of d square into q of x, which is equals to 1 by d square minus 1 into d square plus 1 of sin x, which is equals to 1 by d square minus 1 into 1 by d square plus 1 into sin x, which is equals to 1 by minus 1 square minus 1 into 1 by d square plus 1 into sin x. Here in the denominator d square minus 1. Here we replace that with minus 1 square minus 1. Here d square is replaced with minus 1 square. Thus the expression 1 by minus 1 square minus 1 into 1 by d square plus 1 into sin x is equals to 1 by minus 2 into 1 by d square plus 1 into sin x. Here 1 by d square plus 1 into sin x is of the form 1 by d square plus a square into sin ax, which is equals to minus x by 2a into cos ax. Thus 1 by d square plus 1 into sin x can be written as minus x by 2 into 1 cos x. Here yp is equals to minus 1 by 2 into minus x by 2 into 1 into cos x. Therefore, by solving this, we get yp is equals to 1 by 4 into x into cos x. Thus, yp is equals to 1 by 4 into x into cos x. As we know, the complementary function and particular integral of the given non-homogeneous linear differential equation. So we write the general solution like this. Y is equals to c1 times e power x plus c2 times e power minus x plus e power 0x of c3 times cos x plus c4 times sin x plus 1 by 4 into x into cos x. Thus, the general solution y is equals to c1 times e power x plus c2 times e power minus x plus c3 times cos x plus c4 times sin x plus 1 by 4 into x into cos x. Now some practice problems are given with non-homogeneous terms sin ax and cos ax to learners for practice. So learners, try to solve these practice problems. Let's see what we have learned so far. We have learned to find solutions of non-homogeneous linear differential equations of order n with constant coefficients, which consists of non-homogeneous terms sin ax and cos ax. With this, we finished our unit 3 in the course differential equations, students. Thank you, students.